There's a saying in construction that the architect and engineer haven't spoken together. And what that means is that the architect has gone through, drawn up one set of the plans for the house, what they want it to look like. The engineer has taken those plans, drawn up their plans where all the beams go, the load studs go. They make the architect's plans work. A lot of the time, the architect will have to change the design to make sure that the beams work and make sure the house is actually loaded properly. And they should be going back and forth, making a plan where everything works. The saying is when they don't do that, and the architectural plans and the engineering plans show something differently. And we've got a few problems at the front here, where we've done the beams where the engineer wants the beams to go, but now we can't build the house how the architect has drawn it. And now it's up to us to try to see what we can do to make this house as close as possible to the architectural plans, while still complying with everything. Now, for starters, we do have a hip roof, and it's going to be flowing down into a parapet. I've done this before, and every single time I've done a job with a hip roof flowing into a parapet, stuff hasn't worked, and we've always had to change a few things up. At this point, we've already changed quite a few things, and it's just got to the point where more and more problems kept coming up that I thought it might be worth doing a video on, because it's going to get a bit tricky, and there's going to be a few things we have to do. Now, all of these problems are involved with where the water's going to run off and go. To start with the architectural plan, where there's actually meant to be a box gutter from that wall plate going back that way. That didn't work. We can see we've had to change to a Lear gutter, which is also cantilevering out over past the house. On this side here too, we actually had to drop down all those beams so that these trusses, when they have battens on it, these trusses can flow over that beam, and we'll be building a Lear gutter in here as well, flowing out that way. So that's what we have changed so far. The couple issues we still have is these trusses here will be flown into what will be a parapet wall that we need to build through here. This beam below me should be cut off in line there, and this is all void space here with a parapet wall, meaning that, yeah, that water's just flowing up against a blank wall. That's one of the issues we have to look at and try to fix today. And the other thing is, this is a cantilevering beam coming out here. That stud needs to get deleted. There's going to be a gap between this beam and that beam for a cool architectural feature. But this was meant to be a nibble coming back to this point here, which would not have blocked off the gutter, because the gutter was originally meant to be from this beam going back that way. This was meant to be just a flashing tray flowing back into that gutter. Since we had to pull the gutter over to here, now we can't build a wall through there, or we'll be blocking off the gutter. But I think to start with, we'll build this nibble here and try work out how we can get the water from that corner to flow over here. All right, so I've built that parapet now, and we can really see how that water is just going to flow into a straight wall. So we need to transfer this water to this point here. Through here, we're going to be building a Lear gutter. It originally said a box gutter before the trusses were made. There was no way we're going to get that to happen. The pitch the trusses are at and the set down we needed for the box gutter was not going to fit in the roof space. Now, personally, I don't really like Lear gutters too much. I haven't built too many of them. If you don't really know what a Lear gutter is, we might just jump straight into it and build one now. One small issue we do have with this gutter though is that it is flowing in this way, and we have what looks to be a 210 gap here, and the Lear gutter needs to flow through here down to a downpipe in there. So there'll be a 210 sump. We can make it as wide as we want. I know for box gutters, I probably want at least 300 mil wide there. I don't know what the goes of Lear gutters. I would expect it to be the same. I have chatted with the builder though. He wants me to build it as is for now anyway, and if we got to change it later, we might just need to push this wall out by another 90 mil, which is a lot of work. For now though, we're doing what the builder says, and we're going to make this in here. And quickly, since we are flowing this gutter into this space here, you might be thinking, why can't we just flow the roof straight through here and continue the Lear gutter across? If we look straight down, we have a downpipe at the bottom there. And what's going to happen is that we're just going to get some bricks that block up around the steel column all the way up. They're going to finish about here, and that whole part in there will be open. As I did mention, that beam's going to be cut out, and we're going to be boxing around here. There'll be cladding around this beam here, and then there's going to be a little setback, and this wall is going to be a featured cladded wall going the whole way down. So that's why we can't have any rain heads or anything coming out from this wall here. For this Lear gutter though, it's going to be flowing from that corner coming in this way. And what we want from this Lear gutter is the same as a box gutter, 10 millimeters of fall per meter. This here is, we got about 4 meters, so we'll do 40 mil of fall. 40 mil, I like playing it a bit safe, so we might go at least 45 mil. So we might do 45 mil from this truss here. We'll build the Lear gutter through here, and then we're going to get a little bit fancy here with our blocks and how we're going to hold and secure everything. So our valley board's going to sit directly on the truss on that side, and up here I'm just going to mark 50 mil. We'll mark that through. just gonna hit a nail in there so we can flick a line. Awesome. All right, so now I'm going to cut trimming blocks, going from that chalk line there, coming level across to the truss, which means that the higher I come up on these parapet studs, the further across these blocks are going to go because they're going to be working their way up the pitch. So unlike a box gutter, this lid gutter is going to start skinning out on that side, and it's just going to get wider as it makes its way down here. The way they flash and waterproof lid gutters is they'll put a flashing tray on the bottom here, and it's just going to run up the trusses before they roof on top of that. I'm not the biggest fan, but this is kind of the only way you can really build a roof that has such a steep pitch like this with a parapet that it runs into. So I might cut these blocks at just 300 mil. That should be enough. This gun's going to do my head in today. You're going to see why in just 1 second. Line it up there with that chalk line. I should have started this one. Line it up there. I'm just going to get one nail next to the chalk line for now. And that's why this gun's going to do my head in. It's not necessarily a bad gun. I need to look into it a bit more. I'm just going off from what I've heard in comments, but there is an air canister, which when the battery charges up, it releases a canister and it shoots forward, which pulls the nail out, or it shoots the nail out, I should say. What happens after every single shot is you lose a little bit of air. And I heard that once you get these guns, after about 1,000 nails or so, you're meant to bring it back in, you're meant to top up the air canister, and then it should be good after that. I haven't done that. These nails are struggling now. I am using, I think, 90mm nails, so it's even harder to get them through. Yeah, we can see it sticking through on the other side there. But I need to get that gun looked at for today. It's just going to be a bit of a nightmare. Oh, why did I put those blocks so far away? But all I'm going to do now is shoot one nail on that chalk line. We'll hit that in a second. And then I need to jump down and get a 600mm level, and we're going to level these blocks across. All right, this is the not so fun bit about working by myself. Every time I need a tool, I've got to climb all the way down, grab out that tool, climb all the way back up. Before I jump up, I might also grab some valley board. We need to line the rear gutter with valley boards. It's just going to save me having to jump back down for something else in a second. Good there. I do also want to clear up, even though I'm deciding what we do to fix everything here, everything I'm doing and everything we're altering, I'm running by the builder first. It's not up to me to change the plans. It's not up to me to do any of these jobs without checking with him. Everything falls in the builder, and I just want to clear that up before we start jumping in and trying to adjust some stuff here. So basically here, we'll have a line through there where the valley will be, and we're going to build some trusses starting from this point going up that way. So all the water here is going to flow through to this valley, flow down here to that rear gutter and flow out. And as a start with, this is going back 1260. And if I measure across 1260 this way, I think that's actually perfectly square, which is amazing because it means if it's perfectly square, we can have trusses at the same pitch, have a 45-degree valley in there, everything's going to work perfectly. And at this point here, the roof's basically just going to finish flush there, which is what we want because we don't want this roof to stick up higher and run up there and start to become a bit of an eyesore and cause more issues. Alright, so I'm not actually too sure the best way on how I should do this. For starters, I'm just going to cut a bottom cord through here. We need to make it, finish exactly in line with that wall there for it to work out square. And that may be an issue because this is going to get packed out for cladding. Actually, it should be okay. So we'll give 50 mil here for cladding, and that means we can go past that wall by 50 mil up there. But by the time it's cladded, the roof's going to feel finished flush butting into the wall. I think this should work. So instead of it's 1270 there, instead of 1270, we'll go 1320. So if we go 1320, oh, this wind is hitting us up here. Our roof's 22.5, so I need to go 22.5 off this pitch, which would be, let's work backwards, 90, 70, be 67.5 on the speed square. That's 67.5 there, which gives us a 22.5 degree pitch. 5, 66, 67, yeah, we're good there. So I'm gonna line this through. Cool. That should be the bottom chord of our truss. We'll keep this angle too, because we can make another truss out of it. Actually, thinking about it, I think we can use this bit. This bit should work perfectly for our top chord like that. Yes, that looks good. Theoretically, if that lines up there, I can just measure what the upright is and put that in place. It should work out. I want to do this the right way though, and let's work out exactly what it should be. I'm going to cut something else here at 67.5, which if we do 22.5 in our speed square, I think that should be right. .5, that can make 67.5, and I just realized I'm completely overcomplicating this. I actually don't need to do any working out. All I need to do is measure this, which was 1320, and we've got a whole roof here with trusses already built at 22.5. Before we make any other ones, let's jump up, make sure it works. I've also been thinking for this first one, we probably could have got away with just using the top chord and screwing it into that parapet wall that we made. No harm though, we've got a good strong truss. Let's see if it fits. Nice. Looks very good. Happy with that. And we do have that 50 mil excess at the end there, so that this valley should flow out around that cladding once we put foam on there. I believe that's 50 mil foam going on there. Yes, I probably could have got away with just doing one piece of timber up there, not having to do a fancy truss and just screwing it onto the parapet. But barely used any timber anyway, so now we'll just go through, and I think I'll just make 1-2 more trusses, potentially one truss and just a little noggin or something there to hold our valley boards when we do it, and it looks like it's going to work pretty well. I'll quickly build the other trusses, but one other thing I should say is that these trusses here haven't been built and engineered for saddle trusses to sit on them. There's not much weight here. We're going to be using the parapet wall to support this main truss here anyway, so it's probably going to be fine. But once we do any altercations and build stuff like this, we do need to get the engineer out again to go over, have a look at what we've done, and give us a tick of approval saying that he's happy with everything. Actually, this part might be a bit interesting, actually trying to work out the lengths of these next two trusses. I could do it a couple of ways. I could go over to those saddles and measure how much smaller they get at each 600 mil interval and work it out that way. Instead of climbing over there and measuring them, I think it might be quicker to measure it here. And this is what I'm thinking. I've actually just done a few marks there. The first mark is I butted that level up into the tail of our truss, and I came across to this line which I've marked, which is 50 mil off there, if I get that right. That should be 50 mil exactly to this side of the level. That gives enough for our 50 mil cladding. and this should be the line of our valley where the trusses finish at. I've also done a mark here and a mark there, which is 600 off that truss. The same thing here, which is 1200 off that truss. And what I've tried doing is holding my tape in line with those marks I've done, butting into that beam and sighting down to my level and getting a measurement. So this point here I've got 740, and this point up here, I believe we just got 140. I was gonna run my tape through to that line, but I don't really think we need to for that small truss. So with those measurements, I'm just gonna write them down. We got 140, 740, I believe this one was 1320. 1320. I want to find out the difference between 740, 1320 and 140 and 740. So obviously 140 and 740 is a 600 mil difference. And between 740 and 1320, we got 620 difference. These measurements should be exactly the same if our whole roof is built right. So I want to recheck the measurements. If that was 5 mil off, obviously that's going to make that 605 to 615, and it's going to make it a little bit closer. But as long as the differences between those measurements are exactly the same, it means that we're building these trusses at the right measurement, and this roof is going to flow perfectly up at a 45 degree. Sorry, the valley is going to be at a 45 degree angle. The roof's still going to be a 22.5 degree fall. So I want to double check this. Let's line this up once again. About 50, about there. Honestly, double checking it. It looks like that top, I did measure a little bit off, and I think that top could actually be closer to 120. But if that was 120, it means this measurement here will be 620. Everything works out all right. I could go through and work out some formulas to make sure I get everything exactly right. I think this is good enough though for a small tiny roof like this. Doing it this way and having a look at everything working out is all we need. So 120, 740 bottom chords, let's cut those, shoot them together, and then we can move on with this roof. All right, so I think this roof is pretty much done now. We've got the valley boards laid in place. We can see we've got the valley through there. The only thing I don't like, and I've never really thought if this is ever going to be a problem or not, but it just doesn't seem great having the water flow in this way, coming in on the other angle from the water here, flowing down that way. Just doesn't seem right. I'm sure there's not an issue against it at all. The only thing that could be an issue is how narrow this little lot is through there. So now all that water is going to flow down onto this valley. We're going to get a flashing around here too, so the water's not going to be hitting that frame. It's just going to be going off the flashing and down into the lee gutter. So there's still a few things in the air. We've got to wait for the engineer and both the roofer to come and make sure they're happy with that. I feel like we might be back here changing a few things up. The other issue though was this floating beam here. This beam's doing absolutely nothing in terms of structural load. It's just here for a good architectural feature. We've got this beam through here, and we're going to be framing this up as a 700 wall. There's going to be a 150 mil gap in between. We're going to get rid of the stud too, so there's a bit of a depth in between these two beams. And then we're framing this one up as a 700 wall coming back in the other way, which stops there. Now it looks good from the front, but since we don't have the capabilities to build this little parapet wall back there, we're just going to have this hovering little parapet and then wall floating there, which is going to look a bit weird. So we had to come up with a way to return this back into the frame. I'm not the biggest fan of this. This is the builder's idea, but I can't actually think of a better way to do it. All I'm going to do is get a beam at the same thickness as this, and we're going to return the beam back in, running over this beam down here, and it's going to be the same length of that beam over there, and it's just going to have a double set on that wall holding it. And then we're going to build a parapet wall around it. The wall is probably going to stop around here, and it's just going to float in over this roof here and go back into the frame. It's going to look a bit interesting when it's done. I'm also a little bit concerned if the roofers are going to have any problems having their lee gutter flowing underneath the beam like that, and also flashing the underside of it. That one's going to be interesting. For now though, that's the builder's call. I'm going to put that beam in so it's there. And before we start going through and boxing everything out, we're just going to leave it there for the roofer to come have a look at it, the engineer to come have a look at it, make sure they're happy with everything, and then we can start framing up these parapets, bolting everything off, and getting this whole frame tied off. So this should work pretty well now. That sits on there. Alright, so we've got to imagine that stud's not there, and that's what the final product's going to look like. It's going to come through there, we're going to be cutting that back in there, and it's going to have a drop off where the trusses are there, so it's going to have to get flashed around there. It's a little bit different, and that's just a prime example of the architect trying to play around, make something that looks really cool, but it just does not work at all with the way the roof works and all the beams work. I'm pretty sure this side's going to be mostly right, just with the exception of that which we spoke about. But that's what we're going to get done today, and we're going to wait and see what the engineer and roofer says about what we did, and if we do get the approval to go ahead and keep building stuff the way we're going.